Hi guys. All right, so we are starting unit 4, which is essentially solutions. We'll talk a little bit about what solutions are. We'll do a little bit of math with that. Talk about solubility and things like that. Okay, so real quick, a solution is a homogeneous mixture, which means it's uniform throughout. So when you look at a solution, you can't tell what's in it. You can only see that it's clear or all pink or whatever that is. Solutions are composed of solutes and solvent. The solute is usually what you have a little bit of, okay? So present in small amounts, and the solvent is what is going to be present in greater amounts. So for example, in salt water, your solute is usually going to be the salt. The solvent is usually going to be water. If you're dealing with a solution that has the solvent as water, we term that solution aqueous, and it's denoted by AQ. Okay, so this is real quick how solutions work. This is how solutes and solvents interact. They're very strong solute-solute interactions. So if you think about salt, if you think about sugar, all these different solutes, the interaction between those molecules or those compounds, things are actually pretty strong. And solutions will occur when the solute-solvent interactions are strong enough to overcome the solute-solute interactions, okay? So you have solute-solute interactions, you have solvent-solvent interactions. Solutions happen when your solute-solvent interactions overcome those solute-solute interactions. Real quick, all I need you to know here, when solutions happen and you have water molecules that surround ions, you call those hydrated ions. So you have an ion, you have hydrated, right? You're hydrated when there's a lot of water. When you have ions with water surrounding those ions, they're hydrated ions. The process of making a solution is solvation. Okay, so when solutes and solvent molecules interact, that's the solvation. More specifically, if that process is with water, that's hydration. Okay, so those are some terms that you may see around, and that's essentially what they mean. Water, we'll talk about this a little bit more when we start talking about intermolecular forces later in the semester. But what I want you to know from here is water is polar, which means that it has an even electron distribution. Again, we haven't talked a lot about this, so I don't expect you to know a lot about it. But because water is a polar molecule, it's going to dissolve other polar molecules, okay? It's also going to dissolve ionic substances, which is why salt water would dissolve, or salts would dissolve in water, and things like that. Okay, so note, water is a polar molecule. Just know that. Hold on to that. We'll do stuff with that later on in the semester. I briefly mentioned intermolecular forces the slide before this. Know that there are 4 different intermolecular forces. Again, we will talk about these in more detail as we go on in the semester, but dispersion is the weakest of all the intermolecular forces. Then we have dipole, we have hydrogen bonding, and we have ion dipole. All I need you to know here is, hey, these things called intermolecular, so between molecules, it exists, and this is why solutions form, okay? We'll talk about it later, but just intermolecular forces, this is how solutions happen. So 2 types of solutions with water, right? I could have solutions with ionic compounds and solutions with molecular compounds. And so sodium chloride is an ionic compound. And when it dissolves in water, think back to those hydrated ions. That's how solutions with sodium chloride form. So sodium chloride would break up into its ions, Na plus and Cl minus, okay? And the way the solution will form is the sodium ion gets surrounded by so sodium is positively charged. Polar water molecules being polar means one side is negative, one side is positive. And so sodium is going to be surrounded by the negative part of water. The chlorine, which is negatively charged, will be surrounded by the positive part of water. And that's how the solution forms. For sugar, okay, sugar is a molecule, so there's slightly positive, slightly negative ends, but it doesn't break up into its ions. It's a very similar idea with sodium chloride. The only difference is we're not breaking up into ions. And so sugar has some sides that are positive because there's not a ton of electrons there, and some sides that are negative. And the way the interactions would happen would be, hey, the positive sides would interact with the negative sides of water, and the negative sides would interact with the positive sides of water, and that's how sugar would dissolve. So the molecules kind of are interacting with the water molecules as well. So here's how sodium chloride would dissolve. Here are the solute interactions, right? And water kind of comes in and kind of breaks up those solute-solute interactions to have a little bit more solvent-solute interactions. Or polar molecules, so for sugar molecules, for example, you have your molecule and it's essentially surrounded by water. Okay, so it's not breaking up into ions. Those molecules are just surrounded by water, and when that like overwhelms the compound, the molecule, that's when that would dissolve. Things I want you to know. There's certain things that affect solubility or the ability of something to dissolve. I think the biggest thing is this idea of like dissolving like. So polar molecules are going to dissolve in polar molecules. Non-polar molecules are going to dissolve in non-polar molecules. And the basis for that is this idea of intermolecular forces. Okay, similar intermolecular forces will dissolve. Dissimilar intermolecular forces will not dissolve. When you bring two things together and they dissolve, they mix together, we call them miscible. So they mix, they're miscible. If you bring two things together and they don't dissolve, they don't mix, they're called immiscible. Okay. Water and ethanol, for example, will be miscible. So think about your alcohols, those mix with water because they're both polar. Water and gasoline don't mix. Water is polar, gasoline is nonpolar. Gasoline and CCl4 is a nonpolar substance, will mix, and they're miscible because they're both nonpolar. Here one is polar, one is nonpolar. Here they're both polar, and so they mix. Okay, so like substances are miscible, they will mix. Different unlike substances will not mix, and they're termed immiscible. Okay, hydrophobic. Fear, phobia, phobic, that means they fear water. Hydrophilic, that means they love water. So hopefully you are hearing this in biology. If not, hopefully you'll hear it soon. But hydrophobic, it fears water. Hydrophilic, it loves water. So moral of the story, if it is alike, they will mix. If it is not alike, they will not mix. So a polar and a non-polar substance will not mix because they're not alike. Two polar substances will mix, and two non-polar substances will mix. This vegetable oil is non-polar, and water is polar, and so this is why they don't mix. The end.